Hello and welcome to Key Stage 4 Chemistry topic Identification of Common Gases. Before we get started, can you please make sure you have a pen, a paper, pencil, ruler and a highlighter or another coloured pen and pencil to self-assess. And can you also make sure you're please in a nice quiet room, away from any distractions and no technological devices that would distract you. Okay, before we get started, can you also make sure you please write down the learning objective to understand how we test for different gases. So pause the video just for 10 seconds, just to get that down. Okay, so the retrieval practice will come up on the slide now. So there are 5 questions, so I'm going to give you 5 minutes to have a go at these 5 retrieval practice questions. So 5 minutes, go. Okay, so your 5 minutes are up there, guys. Can you please make sure you've got a green pen or another coloured pen and pencil to self-assess these now. So question 1, what is a pure substance in everyday use? So in everyday use, these examples quite ranging, but for example, milk, fruit juice, cordial, something where you wouldn't want a mixture of anything else in between it. So obviously fruit juice, you don't want some bits of milk in that, and milk you don't want bits of food and stuff like that, other substances that you don't want there. So you just want that itself contained within it. They're pure substances, everyday common uses. But in terms of chemistry, question 2, pure substance is different. Examples are water, so pure water, H2O, not tap water, not salt water, pure water, oxygen, carbon dioxide, and sodium chloride. So they're all elements or compounds. Key part there, elements or compounds. Question 3, what is a formulation? Well, the definition for a formulation is a mixture that has been designed to do something useful, such as fertilizer, which has a mixture of different elements to help plant growth. Number 4, what do we use chromatography for? So used to separate mixtures of coloured compounds that are often soluble, means they are dissolved. And then question 5, why should lines be drawn in pencil when doing chromatography? So it will not affect the results of the experiment, as pencil does not run, the pen ink does in water. So if you're using a pen, it would affect the experiment and make a void result, whereas pencil does not run in water. Okay, so give yourself a mark out of 5 for that for the retrieval practice. Excellent if you got 5, 4, well done. 3 and below, let's just add in the corrections just there. Okay, so this short learning enhancement session is about describing the tests for each one of the common gases. It's all about knowing how to identify them and what apparatus is used, and how to know and identify a positive case of that gas. So the first thing you need to do is have a think, give yourselves 1 minute to have a think about these 2 questions. So how do we test for gases, and then why is it important to test for gases? So give yourself a minute thinking time. If you're in class, a minute, and then 2 minutes discussing, and then jot down a couple ideas in your books or on a piece of paper about these 2. We'll refer to this later on and throughout. So I'll give you 5 minutes just to answer the questions, have a thinking time, and answer those 2 questions and jot down what you can. Okay, so hopefully you've got something down for both of them, guys. As I'm going through it, hopefully we can refer to this as going through it as I mentioned. So hopefully if you've got a ruler or a pencil and ruler, please make sure you have them out. So first thing I want you to do is draw in this table as it is on the screen now. So with the 4 main gases, oxygen, carbon dioxide, hydrogen and chlorine, and then over the next few slides I'm going to go through some information about how you test for it and what is shown by a positive result. So can you draw in this table and resume when you have finished? So you should have got that table drawn in there. Over the next few slides, I'm going to overview and explain how we test for each one of those and what is a positive result. So first one here, making oxygen. You can get down the diagram and fully balance the symbol equation. It just shows hydrogen peroxide being heated up and separated out into its water and oxygen gas. So this is how we extract oxygen from the reaction mixture of hydrogen peroxide, which is H2O2. Just an example there. Now, put simply, to simplify it down, the test for oxygen, testing for oxygen, is simply by putting a glowing splint, which is a lit splint, so it's been set alight, in the test tube of a gas. If the splint relights, oxygen is present, but if it goes out, there is no oxygen. So that's the key part there. Once you get down, so please pause the video, make sure you add that in. Okay. Making hydrogen. So moving on to hydrogen now. So this is where to do this, it's a neutralization reaction. So you've got a metal, magnesium, and an acid, hydrochloric acid, and it makes a salt, magnesium chloride, but then also hydrogen gas. And this is the example shown in the diagram below. If you want to get this down, please pause the video and get it down. And the test for hydrogen, the test of it is simply by putting a lit splint, so similar to the previous one for testing for oxygen, in the test tube of gas. And as you may have heard this before, you may well know this, there will be a squeaky pop sound if hydrogen is present. So pause the video and get this down into your table. Okay, the next one, the test for carbon dioxide. So a test for carbon dioxide, we've got to bubble the gas through lime water, specific liquid, bubble the gas through lime water. And if the lime water does go cloudy, then that means carbon dioxide is present and it is a positive result. So the key part there, lime water will go cloudy if it's positive. If it stays clearer, that means the lime water does not contain carbon dioxide. So pause the video again, add into your table there. Okay, and then the final one, testing for chlorine. It's just a piece of damp litmus paper, which is actually an indicator, type of indicator to identify pH. And if it becomes bleached white, so often the colours on their own, so litmus paper is either identified here, either red or purple. If there's a presence of chlorine, it becomes bleached, which means it becomes white. So that's the test for chlorine. Bleached means it turns white, just in the diagram here. Okay, so hopefully you've got down something for each one of those guys. I'll allow you 2 more minutes to add in anything that you may have missed, and then we'll go for it. So pause the video just for 2 minutes, add in anything, then we'll self-assess it in green pen. Okay, so your time's up there, guys. Can you just make sure you've got a green pen or another coloured pen and pencil to self-assess it? And coming up through here like this. So for oxygen, going splint into the test tube of gas, and the splint relights on fire again. So it relights. If there's no oxygen, it wouldn't relight because oxygen is needed for fire. Carbon dioxide, bubble through gas through lime water, goes cloudy or milky, but cloudy is a better scientific term. Hydrogen, again, burning splint into the test tube of gas, very similar to oxygen test. And a squeaky pop is heard if hydrogen is present. And then chlorine, damp litmus paper. So it's not just litmus paper, it's damp litmus paper into chlorine gas. And then litmus paper is bleached and turns white. So bleach means it turns white. That's a positive test for chlorine. So give yourself a mark out of 8 overall, 4 for the correct tests, 4 for the correct positive results. Okay, so onto the plenary now, guys, and this is the final part of this learning enhancement session. What I want to do is answer these 5 questions. So you're given a statement, you just have to identify what it is. So I'll give you 4 minutes for this, guys. So answer the 5 questions, 4 minutes. Please write down the statements as well, and as well as the answers. So 4 minutes, go. Okay, you're 4 minutes up there now, guys. Can you please make sure you've got a green pen or another colored pen and pencil to self-test these, and then that will be the end of this learning enhancement session. So I make a squeaky pop. That squeaky pop. So what type of gas it is? Hopefully you got that is hydrogen. Excellent. Hydrogen, give yourself a mark for there. Obviously a lit splint is put into the gas, and then if hydrogen is present, it makes a squeaky pop sound. So 2, the gas that bleaches litmus paper is, of course, chlorine. Excellent, if you got that, it is chlorine. Number 3, I turn lime water milky, or a better way of saying it would be cloudy, and that is carbon dioxide. Excellent, well done, fantastic. There. Number 4, a lit splint is used to test for me. So that is hydrogen or oxygen. Hydrogen or oxygen. Excellent. So I've got a mark for one of those. And then number 5, I am produced when a metal reacts with acid. Excellent. It's a neutralization reaction, so that means it must be hydrogen gas. So give yourself a mark out of 5 for that overall. Excellent. If you got 5, 4, well done. 3, good. 2 and below. Let's add in the corrections there and maybe look over our table as well. That concludes this learning enhancement session video on the identification of common gases. Hope you have a great day. Thank you.